I am Dr. Anantaya MB, Professor and Head of Civil Engineering Department, SVIT Bangalore. Today we will see one numerical problem on moment area method, which is of module 3 deflections. It is subject is analysis of determinate structures. The problem is determine slope and deflection at free end of cantilever beam shown. EI is constant throughout. See, this is the cantilever beam. It is shown from A to C. There is a UDL of 5 kN per meter. Then one point load is there at the free end of the beam. The span is given. Total is 5 meter. UDL is for 2 meter length. Then 3 meter length remaining span. See, in cantilever beams already reactions are not required. Directly we can calculate the bending moment. Now I am calculating the bending moment. We know the bending moment at free end is 0. Therefore bending moment at B is 0. See, bending moment at C means my section is now at C. Here I am considering right portion. I am moving from left to right for the calculation of bending moment in case of cantilever beam. To the right, the sign convention is to the right side. Clockwise moments are negative, anti-clockwise moments are positive. Therefore, see, bending moment at C, I have to consider right portion. So it will the only 8 kN load will create the bending moment. So it is clockwise. To the right, clockwise is negative. 8 into 3, only 8 into 3, it is minus 24 kilonewton meter. Similarly, I have to calculate bending moment at A. My section line is here now. I have to consider right portion. I have to come from left to right. All forces to the right we have to consider. Now bending moment due to this 8 kilonewton. See, it is also clockwise about A. Bending moment is 8 into 3 plus 2, 5. 8 into 5 minus 8 into 5. Then the UDL, see, the CG of the UDL is at 1 meter. The total load is 5 into 2, it is 10. 10 it will act at the CG, and the distance from CG to this A point is 1 meter. 1 meter, 1 meter. Therefore it is 5 into 2 into 1. So minus 5 into 2 into 1, it comes minus 50 kilonewton meter. Now I have to draw the bending moment diagram. This is the reference line where bending moment is 0. At B, bending moment is 0. At C, it is minus 24. At A, it is minus 50. Minus 50. Then from here to here only point load is there. The variation is straight line, inclined straight line. But here parabola is there. Therefore here UDL is there. Therefore it is a parabolic variation as shown in the bending moment diagram. This is bending moment diagram. All the values are negative. Now we have to draw M over EI diagram. M over EI diagram. That means we have to divide all these bending moment values by EI. Here EI is constant, not given, means it is same. EI is same for the both portion AC and CB. AC and CB, it is I only. Therefore 24 divided by EI, 50 divided by EI. Then for calculation purpose I am dividing this area into one rectangle, one triangle and one parabola. One rectangle, one triangle and parabola. I made 3 sections. For the triangle, the CG is here. The CG is at a distance of, from apex it is 2/3 of this distance 3. From base it is 1/3 of 3. It is shown here. Similarly for rectangle, we know it is at the center. 2 meter means 1 meter. 1 meter. Then see, this height is 24 by EI, means this height also 24 by EI. Then this is 24 EI, means total is 50 by EI minus 24 means 26 by EI is from here to here. This is parabola. See, I given in the notes. This is the CG distance. For this type of parabola, the CG distance is at a distance of 3/4 of 2. 3/4 of 2. This distance. 3/4 of 2 CG. From here 1/4 of 2. I marked all the CG points in the, see, M over EI diagram. This is called M over EI diagram. Now I am calculating the slope at, he asked to calculate, determine slope and deflection at free end. Slope and at the free end of the cantilever beam. Now we have to calculate the slope. See, this is the beam EAB. If this is the deflected, it is called deflected shape of the curve. So this distance is deflection delta B. This slope is called as theta B, slope. That is slope. This is called elastic curve. See, what is the first moment area theorem? difference in slope between 2 points. I am taking point A and B. Why? Because here theta A is 0. Difference in slope between points A and B, that is theta BA equals theta B minus theta A equals area of M over A diagram between points A and B. Area of M over A diagram between points A and B. See, area means area of this rectangle, triangle and this parabola comes. Now that should be equal to theta B minus theta A equals, what is the area of the rectangle? 2 into 24 by A minus 2 into 24 by A. R values are minus. Next, minus, what is the area of this type of parabola? I given in the notes. It is 1/3 of B into H. It is 1/3 of B means 2 into 26 by A. 1/3 of 2 into 26 by A. Minus, then area of this half into base into height, half into 3 into 24 by EI. Since theta A is 0, directly we are getting theta B equal to, it is 101.33. Therefore, theta B equal to 101.33 by EI. Now we will calculate a deflection at free end B. See, this is the, again I drawn the M over A diagram. In the exam it is not necessary. See, I drawn the M over A diagram once again. Now what is deflection we calculate? See, deflection at a point with respect to tangent drawn from point A equal to moment of M over A diagram, these three diagrams, about point B. See, deflection at point B with respect to tangent drawn from point A equal to delta BA equals moment of M over A diagram between points A and B about B, where deflection is required. Now there are three figures. What is the moment of this rectangle? 2 into area is 2 into 24 by A into its CG distance from B is 3 plus 1. It is 3 plus 1 minus area into 3 plus 1 minus, what is the area of this parabola? 1/3 of 2 into 26 by A. 1/3 of 2 into 26 by A into its CG distance from B is from here to 3. 3 plus 3/4 of 2. 3 plus 3/4 of 2. Next, moment of this triangle, area is half into 3 into 24 by A into its CG distance 2/3 of 3. So it is 1/2 into 3 into 24 by A into 2/3 of 3. That comes minus 381 by EI. Therefore, deflection delta B directly we are getting minus 381 by EI.